Now we're back to the second part of this session. We talk about the CPU. So let's zoom in here. Of course, usually the CPU, most of you know them already. Just in case you don't know what is CPU is something which is responsible for executing, right? Executing instruction and performing calculation. So how the calculation over here, of course, later you can see inside CPU there's different parts. It use the ALU to calculate the instruct. Then there's another instruct part for you to the CU to do so. Basically inside the component inside the CPU. So we talk about the definition over here. Definition of a CPU is basically responsible for executing instruction and performing calculations. Calculation for what? Calculations that power all the processes in a computer. I'm just reading from the slide. Then let us look into detail on this one. Very important. Mark a star over here. More important. Talk about the instruction, how the CPU perform, or they call this the instruction cycle. Or before that, right? Yeah, the instruction cycle. CPU basically from that, then we got the instruction cycle. We start with the first, which is the fetch, fetch. We got the decode, we got execute and store. So we look at the first one over here, instruction, right? How the CPU handle the instructions, or how they operates. All right, they operates is this CPU, they operate based on instructions, right? First they will fetch the instructions from the RAM or the program counter. All right, PC, say the program counter, just telling them what to do, what's the instruction, right? They will fetch the instruction on what to do. Then after they fetch, they will start to decode. All right, decode like over here, basically they're going to determine what to do, right? What to do, all right? They're gonna decode the instructions or the whatever input that you input in, then you execute. All right, this often involves the ALU, which is the arithmetic logic unit. Arithmetic logic unit. Then after they perform this, they will store it into the memory, all right, or the register. this is the sequence that a CPU will go through when they have the instructions. Alright. Next, we look at the components inside a CPU. So over here we got this ALU, which is the arithmetic logic unit. Over here basically it's do all the arithmetic, right? Plus, minus, multiply, divide, right? It does all of this thing, and it processes the data and send it to the register over here, right? The CU, or the controlling unit, the control unit, is another component inside the CPU. It actually helps the CPU, alright, to direct the flow of data between the components and the controlling. Basically it does this, it performs this cycle over here, alright, and like so, alright, it will interact with all the other components. Finally, we got this one over here, the register, which is a small part. As register is something like it's a register. What is this? It's like electronics, alright, it's electronics that stores the data temporarily for further execution after that, alright, then it will perform accordingly. Now here is some more components of the CPU. There's a detailed let me just highlight over here this one. I have detailed notes inside the kit that I will share with you later, talking about the gacha memories. So inside a CPU there's actually a small memory that is small, but it has a high speed memory. It actually speed up the data access, alright, the main purpose. There's different levels of cache memory. Basically it helps to speed up the process and so on. There is actually other components as well. We got the clock. Clock over here is basically what they call clock is like generates, alright, the clock generates regular pulse that synchronize all operations in the CPU. Yeah. Then we've got the bus, BIU, the bus interface unit. Just right over here, this one, bus interface unit. I'm just reading out this one, right? It's responsible for handling the communication between the CPU and other parts of the computer, such as the memory, input and output device. It manages the data bus, address bus and control bus, ensuring that data is correctly transferred to and from the CPU. So basically it's like communication, alright, and the communication between CPU. So the main point over here is communicates. communicate CPU to other parts. So we got the input or output device, which we'll cover on the next session. Then we got this one, the execute unit. This one is the execute unit performs the actual operation as dictated by instructions. It includes the ALU, the control unit, and other supporting components. The EU interacts with the registers to execute and store the result of computation. Basically execute lah. Alright, that's the keyword over here. Then we got the floating point. This one is the floating point unit. This one is also known as the MAD coprocessor, handles the operation involving the floating point number, real numbers, such as division, square roots, and trigonometric function. This is especially important for scientific, engineering, and multimedia applications where precise calculations with real numbers are needed. Interesting, right? Maybe I would say more advanced. Computation, right? I don't know, I'm just putting that up. These are just, I thought of putting in just to create some interest in you to look at what is actually inside a CPU. CPU is not about instruction only. It also has a lot of things, right? It also have a lot of things inside the CPU. We got the interrupt controller. The interrupt controller manages interrupt requests from external devices or internal sources. When an interrupt occurs, the CPU temporarily stops executing its current instructions and process the interrupt, allowing it to respond to important events like a key press or incoming data from a network. Interrupt. So interrupt controller is basically interrupt, right? We got these. The next one is the memory management unit. So let's see what this MMU. Translate virtual memory addresses to physical memory addresses and handles memory protection. It plays a key role in managing system memory by ensuring that each program accesses its allocated memory space without interfering others. Memory management by itself is everything got to do with the management of the memory between the virtual and physical memory address. You want to go into detail? I think you'll kill yourself, right? Just think like this, right? Just think that memory management is to manage the memory in the computer. It's so complex, right? Then we got the data bus, address bus, control bus. These are functions, alright? These buses are responsible for transferring data and control signal between the CPU and other components. So bus interface, right? These are more detail of bus. Data, it transfers the data, of course. Address, it carries memories, addresses to and from the CPU. control buses carries control signal to coordinate actions of other parts of the system. Read write signal. And finally, we got the pipeline. All right, pipeline in modern CPU use pipelining to increase throughput. Pipelining allows multiple instructions to overlap execution, with each instruction being processed at different stage, which is the instruction being processed, right? It actually allows the overlap. Pipeline allows multiple overlap of the just now we learned about the instructions, right? Instruction cycles, so it allowed multiple overlap of this one. Very simple is that you can do multiple tasks. That's actually it about this component of this CPU. Finally, we move to the last part of this CPU types. Is we got the Intel and the AMD. All right, we got the budget version. We got this one. We got the normal one, the i3 to i9 Ryzen, right? Ryzen. For the AMD, I don't know. Let me see what I can find over here. Basically, you can just go Google and search this one, right? Higher means process faster. The keyword is this one, right? The keyword is higher process faster. Alright, higher process faster. Higher what? And then I'd like to also highlight or point out to you the architecture. All right, remember we talked about the bit just now. So those days the computer start with 8-bit, then go to 16-bit. This is the early computer or early processor, right? Early processor. Then we got 32-bit, and then now 64-bit. The processor that can process. Basically, last time it processed the CPU process only 8-bit. So 8-bit, remember just now we talked about over here, they only process this series, right? 8-bit, then it process the 16-bit, means 16-bit, alright. Then it start to increase to 32, and then now the latest is 64. Very interesting. This is one thing that is very interesting. When we talk about architecture of the CPU, right? Architecture of the CPU. They name this like this, alright? For this 32-bit, they call it x86 architecture, and this one they say x64 architecture. So we usually think that this go to here, right? But actually no, it's not, sir. It's from here to here, the architecture. All right, that's it. I'm done with this CPU. Come back to me again for the next part. I'm just touch and go on you over here, right? The main part is that what is inside the CPU. I will do a recap when I end, right?